Good morning, everyone, and welcome to the first in a series of webinars to celebrate British Science Week. The theme this year is Innovating for the Future, something I'm sure we're all interested in. My name's Terry McStay, and I'm absolutely delighted to be hosting today's session, and in particular because I'm going to be introducing someone I've known for quite a long time, Mr. Andrew Turner from Andrew Turner Inventions. I've known Andy for about 15 years, and every time I meet him, which is quite often, he'll say to me, "Oh, Terry, have I told you about that thing I've invented? Let me show you this thing." And it's always something amazing. And it's always something that I think, really, another one, every time I meet you, there's something else. So Andy's very much a serial inventor, kind of a Inspector Gadget, but without the hat. And on his website, it says he solves big problems through simple innovation, and that's exactly what he does. Andy started out as an engineer, and like all engineers, loves a challenge, loves solving problems. But the thing Andy does, as I said before, is he solves those big problems with really simple, clever things that make you go, why has no one ever thought of doing that before? Andy's worked with some of the biggest institutions and businesses in the UK, including the NHS and Northumbrian Water. In fact, 15 minutes ago, I was in a meeting with Andy with Northumbrian Water, talking about his latest invention and how we're taking it forward. But what he does is he simplifies processes and comes up with simple solutions that have saved millions of pounds and so much time you wouldn't believe. And he's also won lots of awards for some of the things he's come up with. So I'm going to introduce Andy in a second, but don't forget, any questions that you've got about the things that Andy is talking about, put them in the chat and put your school name in there, and I'll ask Andy as many of those questions as I can at the end. So I hope you enjoy it. I'm sure you will. And Andy, over to you.
Thanks, Terry. Thanks for the introduction, and everybody, welcome back to the first school day and everything as well for many. I hope you managed to get out of bed this morning. I struggled myself, so what I'll do, I'll just let you know I'm not a speaker or anything like that. I just talk from the heart. I'm going to tell you a bit about my story and some of the projects I'm working on, as Terry mentioned. Some might be interesting to you, some might not, but I've got a half-hour talk to deliver. So without any further ado, I'll dive into that. So if I just share my screen with everybody now. I hope you can see this first slide. Right, so that's me, Andrew Turner Inventions. That's my logo. Leonardo da Vinci had a logo somewhat similar to this, and I thought I'd put the A, the T, and the I into there. Again, I was quite a creative type of guy. I didn't school life. I wouldn't say I didn't concentrate as hard as I should. I was one of them kids who was always staring out the window, thinking of ideas. I was very much on the creative spectrum, but you know, there's a blend between two things, being academic and creative, which helps you being innovative. But I want to just express that being an inventor isn't just about coming up with great ideas. The hard job is actually getting them from idea through into the marketplace, and that takes lots of different disciplines. And I'll just show you a few of. So innovation can be for everybody. It's not just for people who like thinking of new ideas. But let me move on. That's the website that I have. You can log on and see that. I've got an office at the Science Park, of which I'm an ambassador of, in Sedgefield Net Park. Lots of different, exciting new companies work there with brand new technologies, things. But most of my work is done in my garden shed. That's where I'm most happiest. I don't need to be in a big flash office or anything like that to do my work. I can go in my shed, put my music on, and potter around. I've got a load of tools in there, bits and bobs, and I've got a few prototypes around me now, which were all created. Everything I'm working on now is started off in the shed. So you don't need to, anyone can start this job if you want to. I started off, I didn't go to university. I went down the route of taking an apprenticeship, and I took an apprenticeship basically because I wanted to earn some money while I was learning. It was a good decision for me, not since for everyone, but I ended up working in a factory, where I ended up working way up to in a manufacturing plant. I started off as a electrician and a tool maker, Served me time as an electrician, ended up as a tool maker, and ended up working as an engineer inside the automotive industry, where I learned lots of different things, which was a really exciting job. But unfortunately, what happened one day, I had an accident and I injured my thumb. So I was off work for a long time, just as we've all just been off with lockdown. During lockdown, some people might not have utilised that time effectively. I thought, well, I'm off work, I'm going to start working on one of the inventions, which I've always wanted to pursue, and it was related to my job, and it was called Abidot. Now, we used to weld car parts in the automotive industry, and that's a typical what a weld looks like on cars. Yeah, everyone drives around in cars. They're all built by robots. Robots weld them cars up. If that robot makes a mistake, it can be very costly in terms of safety and, failures. If we have to get recalls on cars, it's a really expensive process. So this weld has to be really, really good and repeatable. It has to be right every time. So the robots are just making these things every few seconds, and they could be wrong. So the weld quality was all just governed by people, inspectors looking for problems, where a lot of it was the problem came from the human who actually made that robot laid that deposit of weld down, had done it quite wrong. So I come up with a thing of this is a robot here, and this goes on the end of the MIG welder, and I come up with this new invention that it's got two little lasers in the end of it, and where you go around the weld path, I can actually lay the weld down perfectly, because if you look before, that weld there's gone off track. This one's gone too close, and this one's gone it's too far away from the metal work. So this one's a cold weld, that one's too hot, and that one's out of line. By putting these lasers in the end, I could actually physically see where the weld was going and how far close the robot was to the workpiece. And it used triangulation, a bit like what Barnes Wallace did with the bouncing bomb years ago. He used two spotlights on the wings to see how high the aeroplane was and stuff. So it was the principle's been used before, but not automatic, not in the automotive industry for laying welds down. So it was quite patentable. I got some money. I had to fly over to Germany. I spent about £10 on my prototype. Went to Germany, and they thought I was someone big and a big company or nothing. I just portrayed myself as being a designer in the welding industry. Went over with my prototype and managed to squeeze another £70,000 out of them to take this idea forward. And this bit here. So you've gone from that. This is very early proof of concept to this. This is more advanced proof of concept. It's all, it looks a lot nicer, but this still isn't yet designed for manufacture. So once I've proved all this works and we can make it and we can build it, we did the testing, and then we got another big lump of money to take it to, this is what you call design for manufacture. But that wasn't the easy part of it. The hardest, that wasn't the most difficult part of it. The most difficult part, a lot of it, was doing all of the contracts and stuff like that. You've got to have a patent. You've got to have things called license agreements and all that type of stuff. And I quickly learned how to manage all of that whole process. Me working in a factory, coming from school without hardly any qualifications at all, going into a factory. I never knew anything about legals, nothing. So it was a massive learning curve for us. So I learned how to do all of that, and then in the end rewarded with patents. When you got a patent, it means that no one else in the world can touch your product. You can sell that worldwide, and you can make a bit of revenue from it. Now, people think inventors are millionaires. That particular project, which got me, I left work to pursue it, and it gave me initial £40,000 a year. That £40,000 a year was good. It covered my wage, and it also allowed me to venture into a new career. But just to emphasize, I wouldn't have got into this had I not chopped my thumb off at work, which I thought was the worst thing in my life at the time. But now looking back, in times of adversity, there's something good can happen after it. So I always remain positive and things like that, because you never know what's around the corner. So so this is my second invention I did. And this was me messing about with laser pens. We all seen laser pens before. We can shine a dot on a wall from miles away. They're illegal at the moment, I think. But so I'm not saying mess about with them, but I was very one of these. I used to mess about with all sorts of different devices and tools and pieces of kit. And I come across laser pens. I realized when you shine a laser pen in smoke, you can actually see the beam. Now, emergency lighting, when you use emergency lighting in factories and stuff like that, Smoke to them has the adverse effect. You can't see very well in smoke because it illuminates the smoke, so you can't see through it. So I thought of a way of getting around that. And my initial approach was looking at oil and gas. There's lots of incidents of fires in oil and gas. It's a really high health and safety critical area. So here's my shed. And what I did, I built a row of lasers in the ceiling and I split them so they create a line onto the floor. Now you can't see the beam there. All you can see is the effects of the beam. So what I gathered is if I pass smoke through it, we'd start to see the beam illuminate. And that could be very useful when you're trying to get out of a vacant, exit a building really quickly in terms of fires and stuff like that. So that's the effect I got. Just messing about with my shed, bought some smoke bombs, but built a prototype myself. Probably spent about 20 quid doing it all. But that was enough for me to know now what to do when I'm onto something, is where to go. And so first of all, you go to someone who's can help you take it forward. Someone might have industry knowledge. Someone might have a bit more cash than yourself because this project could be expensive. As it turned out, it was another £150,000 project we had to go through just to get the prototype built. And I thought you could use this thing anywhere to navigate you out of a fire. And I'm just going to show you how it works now. So again, as the last project, that you would never ever just sell that into the market. You've got to take it from proof of concept into design for manufacture. And now you're going to see a bit of footage about how it performed in a corridor. So here you'll see the fires, the alarms have gone off, you illuminate, and then when the smoke starts to fill the building up, all of a sudden the walls start to appear. So it's counterintuitive in the terms that in normal emergency lighting, your visibility gets less and less and less. In mine, it gets more and more and more. The more smoke there is, the more visible it becomes. And that was the really clever thing about the bright route thing. That's with the lights on, you can hardly see where you're going. Lights off, you can see yourself going. You can see yourself going much better. It's a real. And then we had green ones for emergency exits, doorways we can map out. So it was a really clever system in the end. This is another idea I've just done, which is potentially being backed off Microsoft now. We've got problems. All of our drainage all over the UK is underground, and we don't know where it's at, a lot of it, because it was built in Victorian times. All of our wastewater network. So how do we find where all of our wastewater network is? Now we can go around digging holes all day and looking to see if we can hit pipes, but that's not very cost effective. It takes a lot of man hours and stuff like that. There's a thing called artificial intelligence. These are like you class. We can have little electronic devices that we could potentially use and drop down the network and let them float off. And as they're floating off, they can lay a map out for us potentially. So I've come up with this idea of coming up with these small, tiny little devices that you could potentially flush down the toilet, drop them down a manhole. But what happens when you drop them down, do you know where the GPS fix is? Here, you know where you've dropped them off. And every time they go past a manhole, they could send a signal through, or potentially send a signal through the ground. And what you do is you send about 6 of them down the network, and they all float off, and they all start transmitting where they're going. And we can use a map. We either using GPS, or we can use a thing called a 9-axis accelerometer, which is like an underground compass. And magnetic fields are present everywhere. You might not get a signal to the satellite under the ground, but you'll certainly get a magnetic field. So I'm using the magnetic fields under the grounds to try and navigate where these things are going. So on your computer screen, hopefully, we'll see this thing just floating down and mapping out a nice map for us. So from that, this is some of the test results I've had just off using accelerometers. I've took it. This is the actual GPS journey of a car. This is my new system. So yeah, that's the prototype. It doesn't map it perfectly, but it's somewhere near. That's just with my very low-cost prototype. This is it walking around the car park. This is without any GPS at all, just off using compasses. So Microsoft are really interested in this, and with their expertise and input, we reckon we can make this a really accurate line. Therefore, we might be able to do GPS without satellites. We might be able to do it underground using magnetism, which would be an absolute massive game changer for the industry. So we've done some trials. Always build a prototype that's very big. You don't worry about the package size of your invention straight away. Just make it work. That's a big box. Yeah, you're never going to put a float a robot down the network that big, but look, we just need to prove this, the science works first. And we load it in, went under the ground, and we managed to get a trace from it, which was quite accurate. So now we're working on that. There's a patent run on it, and this is the, I'll run this just so you can see what it's about. I'll fast forward it through then. So you've got video now.
As 6 of the Torpedo devices are inserted into the underground, they lose GPS contact with the outside world, but they remain in contact with each other via Bluetooth. Using this method, they are not only able to generate mapping data, but also accurate calculations on various dynamics, such as flow rates, blockages, and choke points. Once the torpedo surfaces, it transmits its stored information via the mobile network to Microsoft's Azure cloud service. Water and sewer companies around the world need to understand the sewage system better to avoid pollutions, with the ability to react before blockages occur, reduce the need to send workers into the sewers, and reduce costs. Torpedo is a major step forward in helping achieve these goals.
So that's Torpedo. The next one is we also have, working with the water companies again, we also have a massive problem with flooding nowadays. Now, being an inventor, yes, it's great coming up with little widgets and stuff, and you might think it's a good idea, but when you come to the marketplace, they say, well, actually, we don't really need it. We're actually doing fine without it, thanks. So you want, if you're going to do an invention with a good idea, you want to have something that someone really needs and they really want it. And some of the best ways to do that is look at industry problems. Now, we all know flooding is a big problem. So it would make sense as an inventor to work on something that's going to assist with the big problem of flooding that we've got, because you know everyone will be looking out for the next good solutions in the flooding areas. So always try and be selective about what areas you want to work in. Some people might think, you know, plastics are, you know, we have to reduce our consumption of plastics and all that type of stuff. These are all good areas to innovate in. Flooding is another one. We've got, if you look at new housing estates, you have these ponds built, sustainable urban drainage systems. And what these ponds are on, they're not there to, obviously they're there for the natural benefits and wildlife and things like that, but they're there as a storage tank for flooding areas. So they can use this pond to actually fill up with water and empty it when they want. So they've got an extra capacity storage system in the network, because we've got nowhere to run. We've got all of our water storage facilities and pipes are all, like I say, built in Victorian times. Our infrastructure is really restricted, so we need to look at innovative ways around it, or else we're getting more and more of this. So everyone could have a water butt on their land, potentially. So when a storm comes, it fills the water butt up first without going down the drain. And then when we're ready, we could empty it down the drain when the storm's passed. So we're sort of taking the load off the system. We're not letting all that rainwater go down at once. We're just controlling when we can not reduce the water butts. But to be fair, I wouldn't want a water butt on my land for that reason only. I think if I was a keen gardener, I'd be a bit restricted using it. It's got a nozzle on there. You can only fill a hose pipe up with it. Sorry, you can only fill a watering can up with it. Doesn't look as nice as what it should. So there's lots of reasons why, as a consumer or a customer, I wouldn't want one of these on my land to fix flooding. But I might have something which looks a bit nicer. So Hydrosols was born. And Hydrosols, again, this is a model I built in my shed. Hydrosols is going to replace your downpipe on your house with a long, tall, thicker downpipe. And what Hydrosols can do now is give you, because it's got a head of water on it, which is long and tall, it can give you a head of pressure here. So now you can plug a hose pipe into it and use it to water in your garden for free. Save money off your water bills. Don't use tap water to do your plants. Use pressurized rainwater to do your plants, fill your fish ponds up, wash your dog after you've been for a walk, wash your car. All these type of stuff, grey water is really good for. But we're not using it effectively. But also what we're doing then is creating a storage tank to prevent flooding. So this was done, you can see here, you can see the pressure at the bottom. One day we'll be able to power toilets with it. It's pressurized. It's going to look, this is just a proof of concept model. I'll show you how it looks, but we can store up to 1,000 litres on a very small footprint all of a sudden, whereas a normal water butt only holds a few hundred litres on a larger footprint. It's got an overflow, it's got a solar panel in it, it's got a valve at the bottom and a filter. So what else we can also do, there's a lot of people now chucking wet wipes down the toilets, which is causing massive problems in the UK. Billions of pounds a year are spent on cleaning wipes out of toilets because people read the packet and it says flushable on the packet. Flushable, anything's flushable. My goldfish is flushable. You know, this cup of coffee I've got in my hands, flushable if I want to break it up and flush it down the toilet. It's a wrong play of words. What it should be is biodegradable because it needs to break down in the water network to stop these things causing problems. So one thing, and they're having to tip loads of water down the network to clean the network out. This Hydrosols, what you can do is actually send a signal and dump a load of water down the network to keep all the drains clean at once, keep them all clean as well and run effectively. But mainly what it's used for is when a storm's coming, we get a Met Office warning. At head office, at the Water Authority, they can press a button and empty everybody's tanks before the storm comes. So now we've got storage capacity in everybody's houses. When the storm does eventually come along, it comes along and it lets the rain down and it fills up all of our tanks with free rainwater to use whenever we want, saving money off our water bills at pressure. So now there's no rainwater going down the network at all. We're eliminating the flood problems further downstream, and we can use all of these type of devices for free from it. We've got, this is the wastewater which goes down the drain. This is our consumer point where we can plug our hose pipe and everything in. It stands up the side of your house. So then you've got to go into things like stress analysis, how much stress is going to be on this thing. When you design it, it can't be allowed to fail. It's got to be able to withstand maybe it's 10 years of life cycle. So it's, you know, it's not just coming up with the original idea. There's lots more work to do, and you can't do it all yourself. You've got to get people in who more specialize in yourself in certain areas and plug all of them gaps around you to ensure that your product's going to be, you know, credible and stand up the test of time. And we've got electronics in there. This is the app that we're going to have. So you're a house owner, you'll have an app which you can just log into. You'll be able to see how much water you've got left in your tank. Head office will be able to see all of the stats of how much rain's fell in certain areas. At the moment, we just say, I live in a place near Newton Aycliffe, and we say it's raining in Newton Aycliffe, but you know, it rains more in certain little pockets of areas than others. So we can get more granular information about how much rain is falling in certain places. And this is really valuable data to the water companies. So we can gather a lot more data, so we can use that to act upon and, you know, build on better solutions in the future. But what I've just done here, you can see there's a solar panel. Solar, everyone's like renewable energy, try and use renewable energy where possible. There's the app, so I can log into my app, and anywhere in the world now, I'll be able to control my hydrocell, and you'll see that here. So this is going through the 4G network. All I have to do is open this valve, and I've got full control of the whole network of hydrosols. So I can basically control the rainwater, and that's it, running from afar. That's the video on that. Then we've got large factory roofs that we can utilize. Factory roofs have got massive amounts of water falling on them. Wouldn't it be great if we could have hydrosols stored around the outside of all of these big tanks like that around the sides of factories? So lots of factories use water in their processes. I know we used to use them for cooling machines down, or if you're working in printing industries and stuff like that, they use a hell of a lot of water. That can all be grey water, filtered grey water. So imagine the amount of money they're going to save from their processes by adopting hydrosols, whilst also help saving flooding. Again, in the water, you're allowed to put raw sewage does unfortunately get into the clean water network because we've got nowhere else to go. We're allowed to put raw sewage into the clean water network, which we all don't want. You know, 200,000 occasions we've had to do that last year, only because we're flooding in areas we've got no storage capacity. If we get more storage capacity in the network, we can then reduce all of these raw sewage going into the rivers network, these spillages incidents, which is again is great for the environment, but also it reduces fines for the water companies. And this is happening often, so we need to reduce that as well. So we've got a storm attenuation system, a water harvesting solution. In dry countries, we want to save as much water as possible. In wet countries, store the water as much as possible. And this has gone through off what I've got a full video on that, which I won't go on to that today. So I'm going to show you a very nice little invention here, which you can all probably relate to, and it's dead simple. There's no high tech, and we have a big problem in the water industry of people getting hurt of coiled pipes. These pipes here, they've got lots of energy stored in them. When they try and pull them out to straighten, they whip back and hit people. So what they do is they tie it to a bucket. If someone doesn't tie that pipe to a bucket when it's outside of the trailer and the knot comes in and it whips up, it's going to hurt someone. So we have to stop it, to the point where we've banned using pipes, coiled pipes now. We're using long sticks of pipes. You'll see here, when it's cutting, how much energy is in the pipe. Now that's a no-no. Someone's going to get hurt again. So we've banned using coiled pipes until I come up with this new trailer. And what we're doing, we're wasting lots of money having JCBs, tying pipes down, all to try and harness the energy in the pipe. Why don't we just kill the energy in the pipe to start with, and then everything else becomes safe? We can go back to laying coils of pipe, which are much more efficient, and no one's going to get hurt. So I got a trailer, and I built a proof of concept, built some test rigs, and this is me putting the pipe through some rollers before it comes off the trailer to straighten it out. So that's a bent piece of pipe, it makes it straight. So this is being tested actually in a place called Annick up the road. There's the new trailer. This is the new piece of kit on the end of the trailer, and they're going to pull it into that long trench, and you'll see now what happens when the rollers, I will just fast. You'll see the rollers, when it pulls through, it's going to go through an arc of rollers and bend the pipe back on itself to take all of its memory out of it. So that's it through the new roller system. I've designed all of this. I filed for a patent and everything on this, but you just pull it off the trailer and it comes off nice and straight. Right the way down there. You can see just laid on the bottom of the trench. Normally that would be whipping up and trying to hurt people. They'd have to put bricks and everything on top of it to hold it down. It can go into services. So you get the gist of that. And this is the end bit where when it comes off, it normally flies up and tries to, it's really, really dangerous. So we've got it tied to the trailer.
Right or slow.
You'll see it come off. Safe.
There you go.
Yeah, no issues at all. And then the same here. Flying up now. All nice and straight. End of the pipe comes off. No problem at all. Now that little idea there, I'll skip through. That's just rosemary top. That little thing there reduced the time from 1.5 days to lay 100 meters down to 10 minutes. So it's a massive efficiency saving, but also a huge, more importantly, health and safety solution. So at the moment, I'm setting up the production of them trailers to try and get them out pretty quickly, because we've started to present them to all the different water companies, and they want them pretty quick. This was on the news a few years ago, which everyone, I'm going to just quickly show you some which is relative, because I know my time's about out. I have got more lined up, but I'll stop after this one, I believe. So this is a school crossing patrol sign. Some inventions come from when something happens to you. And I was in a car once driving, and I didn't see the school crossing patrol member of staff. It was foggy. Everyone's got the brake lights on, all of that. And I thought, you know what? The sign hasn't changed for 47 years. And, roads are busier, congestion and all of that type of stuff. So I actually made a new school crossing patrol sign. And that I wanted to make one which is illuminated. Now with this, when it's switched off, it's got to be performing exactly the same as the current sign, but when illuminated, it's got to be 360-degree illuminated. So there's a quick video here of how it works. I think there, so it works like a normal sign, but when it's tipped up to stop the traffic, it actually slows the traffic down. And we tested this, and the traffic slows down 60% sooner than what it would have without the sign. And the school crossing patrol staff are having lots of things called drive-throughs, where drivers don't see them and they drive straight past them. Now that's going to cause an accident one day. This black stripe on the sign itself was designed to write with a piece of chalk the car registration plate down. So this is hopefully going to reduce the risk to staff. You know, everyone's gone with these new LED lights now for street lights. They're a lot more dimmer than what the old light used to be. So with dark nights and everything like that, that's another potential solution I'm working on now. That one is late. I've been on it for a while because I've been focused on other things as well. So I have got another one there, which is my biggest one, which is going at the NHS, which is all about tracking blood samples. And Boris Johnson's been to see that one as well, because there's big interest from the NHS. It could potentially save the NHS 250 million. And the regional NHS has just won a £75 million contract on that. But it all started in my shed. Everything starts in my shed. That's where I work most of the time. And that's my presentation today. I guess that's just lasted half hour.
Thanks, Andy. That was fantastic, which I knew it was going to be. And can we all give Andy a big round of applause, please, wherever you are? I'm sure you all enjoyed that. So either give him a round of applause or do jazz hands, whatever you prefer. And I'm sure, Andy, you've got another 10 or 15 inventions and ideas bubbling away that we might hear about next year, perhaps.
Yeah, definitely. I enjoy presenting to everyone, and hopefully, the thing is with innovation, you know, you only get maybe 1 in 10 work. So don't be disheartened when they fail, or you do a bit of market research. You might find someone else already done it. That happens loads of times. The amount of people that come to me and say, I've got a great idea, I've thought of doing this, and I'll just go on the computer and go, and straight away there, it's already been done. You can do lots of research yourself to check on your own ideas. But I'd love one day for someone out there to be come up with the next good invention. And if you do, let me know about it.
I'm sure somebody listening or watching this morning, I'm sure that you've already given them some good ideas. So you never know. I'm sure that'll happen. We've got a few questions that people have posted. So is it okay to fire them at you, Andy?
Of course it is, yes.
So the first one was, I'm not sure who this is from because they haven't said, but what would you suggest someone does if they think they've got a great idea for something?
Well, like I've just covered there, first of all, do your research. You know, even Google search and all of that type of stuff can uncover lots of stuff out there if you put in the right keyword searches. And also, don't be scared to wander into different industries to find out, because I've just shown you there that, you know, the pipe trailer I've just shown you there, that was born from an idea in another industry. We used to have to straighten metal out. So I've used the similar principles from that into the pipe trailer. So look at different industries, see what they're sort of doing. Certainly do your research. But if you think that you've got something that no one else has thought of, it could be a mechanical product, could be an app, could be all sorts of stuff. What you have to do is just get yourself a simple non-disclosure agreement, and you can download these off the internet, a template. And all that does, because when you go to file for, if you're lucky enough to get to the stage where you're going to file for a patent, you need to prove that no one else knows about this, because if someone else knows about it before you can't get a patent, because you've got to be the first person to know about it. So how you cover yourself there, you sign a thing called a non-disclosure agreement. So when I go and see Terry with my new idea, I'll say to Terry, before I speak about my idea, will you please sign this non-disclosure agreement about my smart down pipe? And he'll go, yep, and I'll sign that form and I keep it. So that means I'm covered, that he can't go and tell anyone else about it. So do your homework, do your research. Possibly, if you can, build yourself a little prototype. That's more importantly. There's no point in me wasting Terry's time. If I haven't even proved I can do it myself, in some way. Some are more difficult. Software apps, I could never do that myself. But if you're thinking it's a widget, build one. Go in your workshop, find a workshop, do it at school. Go in the, you know, in your craft class or wherever it is, metalwork. Build yourself a little prototype, see if it works, and at least then when I'm speaking to Terry, I've got something to show him, and he'll get what I'm saying. Rather than me trying to explain, I told you I could never really concentrate at school. I'm not very good at English, all of that. But I've got to use pictures and shapes to get across where I'm wanting to say, so I can communicate better with a prototype. So I build a prototype and I show Terry it, and he gets it. He goes, "Yeah, I know what you're on about," and then he signs a form, and I'm covered, and he's seen my idea. And someone like Terry at EC will then help you guide you in the right place. There's lots of support out there. You can't do it all alone. But once you start building up your network of support, your next idea becomes a lot easier, because then you just duplicate it. Your very first one's the hardest. After that, it's easier, because you have to make new relationships. On your first one, you have to forge new relationships. You're going through a massive learning curve. But it's like everything else. Once you've been through that massive learning curve, the second one's easier. So don't, you know, keep going on your first one. If you want to, you've got to really be resilient and sometimes get disheartened. So, but it's an oscillating journey. But people like Terry and RTC are there to help you through that journey, so you're not alone.
Thanks, Andy. Do you have, this is another question, this might be a hard answer, do you have a favourite invention?
My favourite invention, I think, at the moment, is my Tamer trailer, because it's the most simple. Anyone could have thought of that idea. You don't have to know about software. You don't have to know about anything. All it is pipes bent that way, I'm going to bend it back that way. How simple, but for as long as they've been laying coil pipes, no one's ever done it before. And I like that one, because it just proves to show not everything's been invented. You know, everyone thinks, there's nothing else to invent anymore. There is. Someone's just we just invented a trailer that straightens pipe out. How simple. And it was a massive problem. Not only have we straightened the pipe out, it's increased production 50%, 50 times faster, and got rid of all the health and safety issues. So for me, in one foul swoop, it's my favourite, because it's been the easiest to prototype, it's the most simplest thing to build, and it solves such a massive problem. So at this moment in time, that one's my most favourite.
And it's probably true to say that most of your inventions start with a problem that might have been there for a long time, and you find a new way to solve it. Is that right? Yeah,
what I probably used to do is imagine the problem was there, and I'd go to companies and they say, well, it's not really a problem as such. Now I listen to where there's real problems, and I target them real problems. Like my first one, Bright Root, it looks like a great solution. But when you go to the oil and gas industry, they're already compliant. They've got the best health and safety lighting and all that type of stuff. They don't really have to install Bright Root, because they're already compliant anyway. So had I spoke to the industry first, I might not have put that much effort into that one. Although I still like it, and it still will go somewhere, but it's not an immediate, it's not the industry going, we need to get this implemented quickly. They can do it in their own time, because they're already compliant anyway. So
would you say that's where you get the best kind of response, is where there's a real problem that people have been struggling with for years, you come up with a solution?
If it's affecting health and safety, mainly, and then efficiency, anything like that, you know, making things more efficient is always brilliant. Yeah, if there's some, I mean, I'm talking, you've got a thing called business to business, B2B. If you ever see the phrase B2B, it means business to business. These are business to business inventions. You can also have I'm working on one now, which is me to the consumer market. I've got a better way of keeping your toilets clean, to be fair. I know it sounds mad, and I'm working on that. And that's directly signed to the public, potentially through another organization, which is going to save a hell of a lot of plastic. So that's a completely different model to what I'm working on now. But yeah, I've found it much easier on my path and my journey dealing with businesses who tell me they've got this big problem. Can you solve it?
Where do you have your best ideas, Andy?
Normally between about 2 in the morning and 4 in the morning when I wake up during the night. My mind's not polluted with all of your day-to-day troubles, everything like that. You've got lots of social media during the day, all of it is just clutter. A lot of it's just clutter, and it clutters your day up. Then you'll go to bed feeling tired, then you'll wake up wide awake between 2 o'clock, 3 o'clock in the morning, can't go back to sleep, and you're starting to go over things in your head. So I have a little notepad next to my bed, because what I do, I write it down, because then I can go back to sleep better, because I know I'm not going to forget it in the morning. So just to help me get back to sleep, I have a notepad and I write down all my thoughts, so I know it's banked on there. And even if I fall asleep, I'm not going to, because I spend 2 hours thinking about ideas and now worrying in case I'm going to forget them. So by writing it down, I get an extra hour's gift.
And I think everyone's different, aren't they, Andy? I think sometimes when you're trying really hard to come up with a solution to something, that's the least likely time. Because sometimes, I think for me, I usually have my ideas either when I'm in the shower or when I'm driving.
Right.
When my mind's occupied doing something else, and it can just kind of wander a little bit. And that's when some people are more creative, isn't it?
Yes. Yeah. Everyone to their own, you know, I think we live in a life now where we do have to give ourselves that little break to our mind and just go back to just not thinking, then declutter our mind every time. Then, you know, it's like, we're like a computer hard drive. If you try and open too much up at once, your computer will eventually crash. You've just got to let it, you know, clear your hard drive out and get yourself into a state of relaxation. Turn your phones off, turn everything off around you, take all the worries away, and then recharge your batteries. And I think you should do this on a daily basis.
That's good.
Especially, you know, the pressures that we've all just been on throughout the course of the last year. Everyone going back to school, there's a lot of stress in everyone at the moment, and you just need to give yourself a bit of time to empty your tank every now and then.
The last question we've got, what would you say has been your most difficult invention?
I would say it's the Torpedo one, because it's so off the scale, using magnetism. It would. Yeah, I could banter that around certain people. Now, as an investor, if I've got a lump of money and I want to spend £500,000, am I going to spend it on that trailer that I know works, or this thing that I know doesn't work? But if that one works, I get 20 times my money back. That one I might only get 2 times the money back. So for me to get an investor on board for Torpedo was really difficult, which is the only reason why I was looking to get someone like Microsoft in there. That wouldn't normally happen as it did. But even then, that link into Microsoft, I can now use that on other products, but it's a big ask. It's a massive, it's called a high, you get different inventions. The biggest ones are called disruptive technology. And disruptive means there's nothing else like it on the market. It's going to be a game changer. Or you can get incremental inventions, which are, it's like we've got a cup, but now I'm going to put another cup with another handle on. Yeah, it's a new idea, but it does the same thing. It's not high risk, nothing like that. Disruptive technology is when you're going really into the unknown, and it could work, it could not. You take a punt, 80% chance it might work, or 70%, 30% it could fail. Getting an investor to gamble on that with a lot of money has been very difficult, and I'm pleased Microsoft come in on that one, or else that one probably would have been cast to one side now, because you can only spend so long trying to get some of these projects up and running.
And I suppose the good thing for you about having so many inventions on the go is that you can kind of focus on different ones. So some of them are easier than others, and you almost
not focus on any. I got told once. I did get told once, a juggler, when you're juggling 6 balls, you don't just drop one ball, you drop the whole lot. So I only juggle with a few balls at a time. But it just so happens I've got I contract out different areas of my work, and I'm managing. I don't do all of the work myself. People like yourself, Terry, are supporting some areas. As long as your work's distributed, you can manage a few projects at a time, but don't take too much on, because yeah, you can dilute them too much. And if you think about it, every single project is different, and they've all got different stakeholders. Stakeholders are people who are interested in your project and maybe put some cash into them or something like that. You've got to keep them all happy. You know, you don't want to let these people down, so you can't take on too much.
We've just got. So I said that was the last one. We've got one more question that's just come through, and this is probably going to be quite a hard one to answer. How long has it taken you with each invention, from when you've had the idea to when it's actually being used?
So they're all different. The NHS, which I didn't show you, which is my biggest one, which is going into trial now. That's took 2.5 years, which is fast to get the NHS, to be fair, given the organisation I'm going into, which is very heavily regulated and stuff like that. The Tamer trailer is 18 months now, ready. We're starting production, getting into production, because yeah, I've had to fit into other people's diaries as well in terms of trials, testing and stuff like that. So I would give yourselves a couple of years. It doesn't happen fast. Give yourself a typical invention. If it's a widget going into a toy shop, a little toy thing, or you might do a bit quicker, but it depends on the industry you're going into, how heavily it's regulated, and also finances as well. Finances will slow you down. So I would give yourself a range of about 18 months to 3 years. Typically, you come up with an idea and get it implemented into the marketplace. Having a prototype and everything, by the way, can take you only a few weeks. It's really exciting once you do that. You think of an idea, and within a few weeks you've got a solid working prototype, whether it's an app, whether it's a piece of software, whether it's a new widget. You can have that done pretty quick. There's lots of support out there to get your prototype up and running pretty quick. It's the slowest things are what happens after that, when you're going through all of the rubbish bits. The boring bits, I find them. The most exciting bit for me is the prototype side. But you've got to do it.
We talk to a lot of people who've had a great invention and a great idea, and they think that's the hard bit. And I have to say, no, you've done the easy bit. The really hard bit is actually making it work and getting people to buy it. Yeah.
I mean, again, it's like I said before, the innovation process, I'm not very good at the legal side. Some people might be interested in that. Some people might be interested in all of the data and the maths and everything behind it and all of that. Yeah, I'm more on the creative side. So I find all these other topics within the innovation process more difficult, but innovation can be for everybody. Someone might like themselves the legal side of it. Then you might want to look at being a patent solicitor or something like that. There's all sorts. The contracts even are they're a different legal entity. Then you've got people who can actually build the design, do the design for manufacture with using AutoCAD and all of that type of stuff. It's a massive skills. It's a massive resource pool you need to utilize. But I'm on the more what's the word I'm looking for again? Creative bit of the process. But being nice and kind to people and getting them on board and having a good work relationship with everyone's also key. It's a team effort.
Okay, thanks, Andy. I'm sure we could talk about this for another hour at least, but we'll have to leave it there, I'm afraid. I've really enjoyed, I've heard some of those stories before, but I don't get tired of them. And I'm sure next time I see you, you'll have another 2 or 3 inventions that you've come up with in the middle of the night. So maybe if we come in British Science Week 2022, we might ask you to come back and tell us about how those things have gone on and some of the new things that you've come up with. But in the meantime, we wish you all the best with the inventions that you're going through, and we'll look forward to seeing them out there in the market. So Andy, a huge thank you from me and all the people watching.
It's been a pleasure. Thank you, Terry. Good luck, everyone. Take care.
You're very welcome. So I hope you've enjoyed that. Don't forget, we're here all week. So we're here at the same time tomorrow as part of British Science Week. Look forward to seeing you then, and have a great day. Thank you. Bye-bye.